Hello everyone, today we are going to be talking about our mobile application Hangout. First we are going to introduce our team, then we're going to demo our mobile application Hangout. We will walk through how we hosted Hangout in the cloud using Google Cloud Platform. We will give an overview of the total cost to deploy Hangout in the cloud. We will discuss next steps for Hangout, and we will answer any questions you have.
Everyone, I'm Jack.
I'm Zach.
And I'm Brigitte. We are all computer science majors graduating in May.
So the app we decided to work with, we had built for a previous class, software engineering, in our last semester. And in that previous time, all the backend was hosted in AWS, and it was an EC2 instance for our routes and Amazon RDS for the SQL side. So the purpose of Hangout is basically it allows users to connect with each other based on a shared activity, such as you both want to go bowling, so you swipe right on bowling, and you can match with other people who also want to go bowling. For the technical side of Hangout, in the front end, our UI is running on React Native, and the compilation of our app is done by Expo Go, which is how we tested the app and saw how every component would look. In the back end, we have a MySQL database, and we are using Express.js to run our routes and for the APIs. So some of the modifications and extensions we made, we ported everything over to GCP, and we have an Express API running our Cloud Run instance, and then our database is on Cloud SQL. We have a few bug fixes and UI changes we made. We added the ability to upload profile pictures. We added a clickable option to see more activity details about each activity. And we also added a button that allows users to suggest activities to be added to the card set. So here's a quick summary of the GCP technologies we used to make this happen, which we will go more into detail after the demo. And here's the demo.
When you open the app, you are directed to the login page where you can create an account if you don't already have one. So I'm going to go ahead and create an account. And now I'm going to log in with those credentials. If I accidentally input the wrong password, then it gives me an error message. And in the database, we hash each password so that they're stored securely. So now that I'm logged in, I'm directed to the home page. The home page contains a deck of cards that have different activities. So we have 3 different activity types: physical activity, arts and culture, and food. So you can swipe left and right on activities. You swipe left on activities you don't like and right on activities you do like. So you can either swipe or you can press the green check mark or the red X. But before I keep swiping, I'm going to go to the My Profile page and input some basic profile information. So I just saved my profile, and you can see that my profile picture is updated. This is also where I go to log out of my account. if I want to log out. So now I can go back to the home page and I can swipe right and I can swipe left on activities. And I can also look at the details for each activity. So if I go to details, I can see the address, phone number, photo URL, maximum group size, city, state, and zip code for Taco Bell. I can also go to the My Groups tab to see what groups I am currently in. So right now, I'm not in any groups. But I can swipe right on Taco Bell and I can see that there are 2 groups formed already. I can either join one of those groups or I can create a new group. So I will join this group with Zach. So now if I go into the My Groups tab, you can see the new group that I joined and it has Zach and I can press on Zach's profile to see his profile information. So in the Home tab, I can also press the little plus symbol to suggest a new activity. So this is if I want to add an activity to the card deck that does not already exist. So I'll add an arts and culture type activity. Let's do the Fort Worth Rodeo. So now that activity has been submitted and will show up on the slide deck. So let's say I want to go to Truck Yard. Let's create a new group. So I want to go with 4 people. Let's go on Thursday at 7:30 p.m. So I just created that group, and anyone else who swipes right on Truck Yard has the option to join that group, or they have the option to create a new group. So now if I go to My Groups and refresh, we can see that Truck Yard has been added. So now if I want to log out, I go back to the My Profile page, scroll to the bottom.
So I'm going to be going into more detail on how we actually implemented Hangout using GCP. So Hangout being a mobile app, the front-end code is all downloaded locally onto each user's smartphone. So we aren't using any cloud technology to host that. The cloud technology comes into play with the backend. So the first big component of that is our relational database, for which we're using GCP's Cloud SQL. So here we have our Cloud SQL instance. We decided to go with the minimum spec configuration to save on costs, because we figured we would, based on our database is mostly text. So we just have a small amount of storage, and it really saved us on the costs. And here we have our Hangout database, and the Express app connects to that database using this Hangout user rather than the root user. So the next big component of the backend is the Express.js API. And so this is a service that we built using Express.js for last semester. And we improved upon it this semester by actually containerizing it. Last year, we had just had it running as an independent EC2 instance. So we containerized it with Docker, and we built it using Cloud Build. You can see all our build logs here. And then the final image is uploaded to our public container repository. And so here we have the history of all our revisions to the backend image. So going back to Cloud Run, here is our actual service that's running right now. And here's some of the metrics and logs for that. So the way this service works is it's a simple web server that takes HTTP requests and then queries a database and sends a response back to the individual users. And so to go into the configurations for this, we are using our latest container image here. Again, we went with lower specs because we anticipate a low load. And so in order to save costs. And so we have the minimum number of instances set at 0, so that, again, to save costs so that we don't always have an instance running when no one's using it. And we have a maximum of up to 5 instances of the container. And here we have all the variables and secrets that are used by the Cloud Run instance to connect to our Cloud SQL database. So these secrets are managed separately in the secret manager and exposed as environment variables here. So we have obviously the database username, password. The instance connection name is the name of the Cloud SQL connection, which is required to connect to connect to the Cloud SQL database from Cloud Run, and the name and the IP address of the database. And so that is all of the info for our Cloud Run service. Next, we have the CI/CD pipeline implemented using GitHub workflows. So here we have our public GitHub repo with all our source code. And so in our workflows folder, we have this build and deploy workflow. And what this does is authenticates with Google Cloud, and then submits the build task to Cloud Build, and then finally runs this command here to deploy, to actually deploy the new revision of our to Cloud Run. And so as you can see, we have all the settings specified here, like the port, the secrets, and the connection name.
So this is alerting, and as you can see, I have a few different kinds of alerts that will send me an email if something goes wrong with the SQL server or possibly the Cloud Run instance. So high number of containers spun up. This could tell us there's a large amount of traffic going on just to monitor it. Large amount of SQL used. That just means, hey, we may need to look at how much money we're using, or many requests quickly. That could be indicative of a kind of attack, a DDoS attack or something like that. And we also have this BigQuery set up, and this is basically just a bunch of Cloud Run logs streaming into these tables so that we have, instead of a rolling storage of the last 30 days, we have every Cloud Run log that has taken place and it's stored forever. And we can just run a SQL query to quickly figure out what is maybe a past log or something. And that's why that is useful.
Right. The last component that we have to discuss in the cloud is the HTTP load balancer. So originally we were just connecting to the database using this public URL for the cloud for an instance. But we decided we wanted to go with a load balancer to support future scalability. And so we set this up using HTTP, which has this IP address for our service. And so now all our individual clients have this IP address inside the source code in order to make the API calls to this address. And then our load balancer communicates with our Cloud Run service and then returns the result to the user. Finally, we're going to talk about the implementation cost. So we spent about $10.20 at this moment in time, and we're projected to spend $11.69 by the end of the month. And so let's look at the cost breakdown. The primary cost is the Cloud SQL instance, which even though we went with minimum specs, we still have 10 gigabytes of storage reserved. We're using about 2 gigabytes at the moment. And that ran us about $8. And then Compute Engine, that cost, although we're not using Compute Engine at the moment in our final product, we did some experimentation with some Compute Engine features, but decided not to go with that solution in the end, but it still cost us there. And finally, our cost for Cloud Run is 10 cents, which makes sense as that was our that was the primary thing we had running in the cloud for communication between the front end and the back end. But since we had a minimum of 0 instances running at a time, we did save a lot of money, only costing us 10 cents. So to close, I'm going to be talking about the future of Hangout and some extensions we might make should we decide to continue development of this project. The first of which would be making use of the Google Places API. The Google Places API would allow us to take the user's location and then find relevant activities, places, restaurants, etc. near them, and then turn these into cards that they can swipe on. Next, we would look at implementing a group chat feature to allow users to communicate more efficiently about meeting time, place, etc. On the technical side of things, we would look at migrating our database to Firebase. The advantage there would be offloading the authentication process onto Firebase rather than using our own SQL database. Finally, we would look at exporting our React Native code into React.js so we could have a version of the app that runs on a web browser, so users can access the app both on the web and on their smartphones. And that concludes our presentation. Thank you.